All right. Good morning, good afternoon, and good evening to all of you present here who have joined me for this webinar on GMAT Algebra. Now, before I begin anything else, I would want to check the audio with all of you. Can you please mark a yes if you all can hear me clearly? All right. Thank you for all of your responses. What I'll do is I'll end the poll and hide out this poll over here. So, welcome to this webinar. In this webinar, we are going to solve some amazing questions, and I'm going to help you understand how to solve questions based out of inequalities, quadratic inequalities, and absolute values. The three most important and the three most feared topics, I would say, in GMAT Algebra. Now, this is a very application based webinar, and that is the reason we had sent you some concept videos for your perusal, and I hope that all of you have already watched those videos. If you have not watched those videos, it's completely all right. I would request all of you to watch those videos after the session is complete. Right, with that, and then where are these videos located? Just log into your free trial account if you have a free trial account or a paid account. All of that is located under Quant, under Algebra. Right, so with that, let me hide this poll over here and let's talk about the next set of sessions. Now, we at e-GMAT conduct sessions every weekend, both on Saturdays and on Sundays. The next Saturday, that is October 23rd, we have a session on GMAT reading comprehension. And in this session, we help you understand how to pre-think to tackle difficult CR questions and get them right under 2 minutes. Right, it's a very important session. So if you are anyone who's struggling with critical reasoning or your score has plateaued in critical reasoning, you can attend this session to make sure that you're perfectly good to go as far as GMAT CR is concerned. The next day, that is on October 24th, we have a GMAT geometry webinar. In this webinar, we help you understand how does concepts and process skills help you excel in GMAT geometry. Here we discuss a lot of cool questions based out of quadrilaterals in GMAT, right? So to register for both these webinars, simply click on the register now button, the yellow buttons that you can see on the screen, and that will get you registered for these two webinars. With that, let me hide out this pane, and I have two questions, or rather three questions to all of you. So let me hide this out as well. So the first question is, when are you planning to take the GMAT? This gives me a very good idea on the people who have joined me for this session. That's the first question. So put your answers if you have not done so. And then I have two more questions for all of you. The first question being, what is your current quant score? And obviously, you can predict the second question, right? The second question is, what is the target quant score? And let me broadcast the results over here as well. And let's see the answers to these two questions. And if you are wondering where's 51, 51, there's at the end. So you just might have to extend the poll a bit. Okay, thank you for all of your responses. Now, what I can see is the break of the class is very, it's very similar to the last session. Now, I see, the percentage of people taking the test in all these five categories, apart from the last one, is fairly similar. But yes, I see that almost 50% of you are taking the test beyond a month and a half. So if you belong to the first category or the last, through this webinar, we would help you understand, the different process skills and the different concepts that are there to ace GMAT Algebra, right? And I'm very, very sure after the session is done, your confidence in algebra would definitely rise up. About the current quant score, I only see a handful of people in that Q49 plus score. Anyone who's below Q48 and even in that Q49-51 range, hugely going to get a lot of output from this webinar over here. And then I'm very also happy to see that almost three-fourth of the class want to get to that score of Q50 and Q51, which is great motivation. Now understand, keep your goals high, and that's one thing that you have to make sure that you keep your goals high, because if you do not, getting to that becomes more difficult, right? And this provides your motivation. That's very, very important to help you reach to that target score. So thank you for putting in all your answers over here. With that, I'll go to the next screen. In the next screen, just give it around 2-3 seconds. The presentation would load up, and let me get you the poll as well. Just a moment, please. All right. So if you all can see my screen, please mark a yes. That is perfect. And I'm so very happy to see so many votes that you're polling. That is good. So what I'll do is I'll end the poll over here. Just a moment, and let me clear all the answers. Now, before I move ahead, 2-3 logistics pointers that I want to specify. Towards the right hand side of your screen, you can see a chat pod. Now in this chat pod, we'll take all the questions that you have around the questions that we would be solving. Also, this chat pod would be used for any question that I ask, and I ask you the answer to. You can also see an empty space above that. Now in this space, I will give you the polls for marking the answers of the questions. Since we have a live chat pod, please take a note. Please do not put your answers in the chat pod. This is a request to all of you. Please do not put any answers in the chat pod. At the end of your screen, bottom of your screen, I'm sorry, you also have a Q&A pod where my co-host today would help you answer any questions that you might have during the entire session or with respect to any questions. Now, let me introduce myself. I am Athreya Roy, and I'm one of the strategy experts and SM experts here at e-GMAT. And supporting me today is my best friend in the company and a senior strategy and SM expert, Harsha. So today both of us will make sure that any questions or doubts that you people have are taken care of. Number A, and number B is any other questions or concerns that you have around algebra are taken care of. And definitely the session that we have brought to all of you, we will make sure that we impart the most of the learning that we have brought for you in today's session. Now, just to see that if the chat pod is working and all of you are completely aware with that, can you please type in a hi in the chat pod so that I am aware that you people can hear me, and we are good to go. That is perfect. All right, so let's get started. I would give you the poll for the first question, but even before that, and before that, let me do another thing, and let me ask you all another thing. I won't time all of you in this session. What I would do is I'll give you a poll for each and every question that we would be solving. What you need to do is you need to mark a still solving on that poll right at the beginning. And once you mark still solving, I'll give you the question. Once you have the question, you solve it out, you mark the answer in the poll itself. When I see 80% of people who essentially marked a still solving, then chose another answer choice, that's the time when I call time. So calling time for me is what you people would take at an average to solve this question, right? I won't time yourself. Your average time would be the time that I'll clock, right? So let's get started, and let me very quickly take the pen as well. Let me take the red colored pen and hide out the palette. Perfect. So how would we go around the entire session? The first 15 minutes, we'll talk about your feedback and your current conceptual ability. We'll give you some questions, and then we'll discuss, based on those answers that you would be putting in, what is your current conceptual level, and what do you need to do to make sure that you are good to go as far as the concepts are considered in algebra. Then the next 1 hour, we'll be solving a lot of questions, and we'll be focusing on process skills to solve questions on GMAT algebra. And here, you'd also learn how to use those 6 different process skills that we have to make sure you don't get questions incorrect, or rather while you're attempting the question, you have all the tools to make sure that your question is not incorrect. Then the last 1 hour will be solving some whatever we have learned in the previous 2 sections. We'll use that learning and solve out questions which are typically of that 700 or plus level of difficulty. Okay, that is good. So let me move ahead to the next part and just give me a moment. So we'll talk about the concept related questions first, and basis that I would give you the first poll. Now, all of you already know the process. I am very sorry. Let me clear all the answers and reopen the poll over here. What I want all of you to do is mark a still solving, please. I've opened the poll. I want all of you to mark a still solving. And how many people do I have? I have 100 students. So let's get 60 people mark a still solving. The moment 60 of you mark a still solving, I would share the first question. So the faster you mark a still solving, the faster you get the question. I only have 55 people. I need 5 more volunteers. That is perfect. All right, so let's get started. The first question on your screen, all the best for All right, last 5 seconds to mark the answer for this question. 5 more seconds. If you have not marked it, please do so. 3, 2, and 1. Perfect. Let me end the poll. And we'll not broadcast the results right now. We'll bring up these polls once all the 7 questions are answered. Or what I can also do is I can also broadcast the results. It's all right. So let me do that. And what do I see? 74% of you tell me that the answer for this question is choice B. All right. That is noted. So we'll move on to the second question. Just allow me a moment. Okay, the poll for the second question is up. I hope all of you already know the process. Please mark us still solving so that I can give you the next question. I need 60 representatives who mark us still solving. Only then I will be able to give you the question. I only have 56 people. I need 4 more. 58. 50. Still 58. Okay, interesting. Okay, I have my 60. Question number 2 on your screen. All the best for this one. All right, let's see. I have let's take another 5 seconds to mark the answer if you've not done so. I almost have 50 responses. Three, two, one. I'm going to end the poll and broadcast the results. So what I can see over here is 68% of you tell me that the answer for this question again is choice B. Okay, interesting. I guess yes, you people are correct, but we'll again take a look at the end, right? So let me hide this poll over here and get you the question, the poll for the third question. You have the poll. Can you please mark a still solving? Okay, that is perfect. Question number 3 on your screen. All the best for this one. All right, last 5 seconds to mark your answer. Three, two, and one. Let me end the poll. And so I have gotten 3 responses about where is option E. Now, since option E is not in the poll, again that's not the answer, but yes, I'll make sure that the option the last option is also there in the poll. I am sorry for that, but we'll make the changes next time, right? But yes, one option that can never be the answer is option E, because I don't even have the poll. I'm just kidding, but yes, that can never be the answer. Okay, so thank you for all of your responses. Let me broadcast the results. 68% of you go with choice C, and then the next favorable choice is choice B, where 9% if you go with choice B. Fair. Let's move on to the fourth question. And I have the poll for the fourth question. Please mark a still solving. All right. Question number 4 on your screen. All the best for this one. All right, last 5 seconds. Last 5 seconds to mark the answer for this question. If you have not done so, please do so. 3, 2, 1, and 0. I'm going to end the poll and broadcast the results. Now, this question gave you some fight because I see only 55% of you chose choice C. 23% of you have chosen choice A. So we are going to discuss this solution, and we are going to get a lot of perspectives of why did you falter in this question. With that, let me move on to the fifth question. But before I move on to the fifth question, in the chat pod, are you liking these questions? Perfect. All right then. Question number 5. The poll is up. Can you please mark us still solving? Again, these are warm-up questions, guys. I'm just warming you up for the next set of questions that we have. I'm very sure you would enjoy those questions at all. Okay. Question number 5 on your screen. All the best for this one. All right then, last 5 seconds to mark the answer for this question. I'm very, very sure this was slightly more involved by the answer choices that I am seeing over the poll. 3, 2, and 1. I'm going to end the poll and let me broadcast the results. 52% of you chose choice C, 25% of you chose choice D, and the 9 and 8% respectively going with choices A and B. Very interesting. Okay, that is good. We'll move to the next question. Question number 6. Again, all of you know the process already. Please mark as still solving. I have another question for you. So this is question 6, and then I have question 7, and then let's discuss the answers to all these questions. Perfect. Let me move ahead to question number 6. All the best for this one. All right, last 5 seconds to mark the answer for this question. Please do so if you have not done it yet. Three, two, and one. Okay, I'm gonna end the poll and broadcast the results. Quite a majority. I can see 77% if you're going with choice C. The other most favorable choice being choice D, which 10% of you chose. Interesting. Okay, with that we come to the end question, to the last question of the warm-up section. Let me get you the poll. Okay, you have the poll. Please mark as still solving. That is perfect. Let me give you question number 7. All the best for this one. All right, 5 more seconds to mark the answer for this question. 3, 2, and 1. Let me end the poll and broadcast the results. Now, 46% of you tell me that the answer for this question is choice C. 36% of you, man, that's way too much. Tell me it's none of the above. I would go into asking you why is choice D. Why have you marked choice D? But let's take another moment over here and then come to discuss this question. So with that, let me bring the poll over here. I do not need the poll a lot right now. And let's answer in the chat pod, how were these 7 questions, guys? Tough? I wouldn't say they were tough. They were easy to medium, right? Again, please understand these are warm-up questions, and they are of the level of 650 or lower. Some around 650, but yes, they are around that 600 level. So not that difficult for sure. Okay, that being said, out of these 7 questions, how many do you think you got correct? 7, 6, 5, 6 or 7? Okay, that is good. That is good. All right then. So let's get to the feedback session and let's understand what do we do basis the number of answers that we had gotten correct in these 7 questions. So let's have a very clear understanding of what are the next steps now. These were the first 3 questions where you had to find out the range. In the first question, we had 1 inequality. In the second, we had 2. In the third, we had 1. The answer for the first question is y greater than -2. The second question, y greater than -2. The third is x belongs to, or x is from -infinity to -2. Now, if one or more questions that you solved over here were incorrect, then you have major conceptual gaps pertaining to linear inequalities. Please understand, these are very basic questions. These questions just test. Yes, I'll show the answers, Thomas. These questions just test what is your current conceptual ability as far as solving linear inequalities are concerned. We had a single variable inequality, we had two variable inequalities. Again, very simple questions, not at all that difficult. We want you people that we want all of you to solve these questions, you know, within the shortest amount of time. But yes, if you cannot, there are some conceptual gaps and we need to fix them out. Let's be honest about that. That's number one. The second kind of questions where we went into quadratic inequalities, where we had a normal quadratic inequality and then a fraction. The first answer is choice C. The second is choice C again. Now, if you had any of these two questions incorrect, then again, the problem over here is you're not that good with the concepts of quadratic inequalities and you have to go back to the course or your free trial and check out how are quadratic inequalities solved. Obviously, we are going to discuss the solutions, but this is a feedback that you definitely want to keep, and then you definitely want to revise those conceptual files that are there under these two topics. Lastly, the two questions on absolute values. The first answer is choice C. The second, again, is choice C. And again, if you had gotten any of these questions incorrect, you need to go through the absolute value files because there are some major conceptual gaps. Understand why are we saying that there are major conceptual gaps? The reason behind this is these questions are fairly simple. When you would be the answer for the seventh question, Ahad, is choice C. That is A greater than equal to B. Okay, so what I was saying is these questions are fairly simple questions. In your actual GMAT exam, the level of questions that you would be getting would utilize much more high level application of the concepts that we have just seen, right? So we have to make sure that all of these which we'll be learning in the next slides are completely clear to all of us. So with that, let me just shorten this poll a bit and let's go to the next part. Now, please understand, we only are conducting a 2-hour session, right? However, we would be giving you feedback, but the feedback would not be that refined or that detailed. When you go to our Con 2.0 course and you take the diagnostic quizzes, the diagnostic quizzes are defined and designed in such a manner that they'll tell you exactly the points where you are lacking, and then when you have a clear understanding of your weaker areas, you can work upon them. So go to your course, understand how and which areas are the ones that you are lacking at. So basis the diagnostic test that you take, we suggest you out of the files that you see on your screen, which ones to do for inequalities, for linear inequalities, quadratic inequalities, and absolute values. And then basis the score that you get, we suggest you that since you have gotten the score, you need and you must do these files, right? It's a very adaptive learning platform, and I'll talk about that in a later bit, but yes, please make sure you do that. Now let's discuss the solutions to the three questions we just now solved. Question number one: what is the range of values of y when I have been given a linear inequality 4y plus 10 is greater than minus y? Now, the process of solving these kind of questions are very simple. What you need to do is bring the like looking terms on one side of the inequality. So I have two kind of terms: the terms with the coefficient of y, and then the terms which are constant, which is, for example, the number 10 over here. So I'll try to bring similar looking or like looking terms to one side of the equation inequality. So what would I do? I'd bring this minus y to the left hand side. I'll take the plus 10 to the right hand side. So when I bring minus y to the left hand side, it becomes 4y plus 10 plus y to be greater than equal to 0, or essentially 5y plus 10 is greater than 0. I'm sorry. And then when you bring plus 10 to the right hand side, that plus 10 becomes a minus 10 because it is changing the sign, or essentially you can just consider this process to be subtracting 10 from both the sides of this inequality. So by subtracting a 10, this 10 vanishes off, and when I subtract a 10 from 0, I get a minus 10 at the right hand side. Finally, I divide both the sides of this inequality with 5, and I get the value of y to be greater than minus 2. Hence, the answer for this question is choice B. Fairly simple, not at all a concern over here. But the takeaway for this question is to solve linear inequalities, always make sure that you bring like looking terms to one side of the inequality. Right? With that, let's move on to the second question. Okay, the second question is slightly more involved than the first question. Here we have two linear inequalities, and that's the reason we are having two variables as well, which are x and y. I need to find the values of y. Now tell me, if I need to find the value of y or the range of y, what do I need to eliminate? Do I need to eliminate x or do I need to eliminate y from the two inequalities that I have? What do I eliminate? Do I eliminate x or y? I would definitely eliminate x, because the moment I eliminate x, I would get to the values of y. So x minus y is greater than minus 3, minus 2x plus 3y is greater than 4. I see that I need to eliminate x. I have a minus 2x over here. I have a plus x over here. So what I do is I multiply the first inequality with 2. What do I get? I get 2x minus 2y to be greater than minus 6. Now when I add these two inequalities, because I know that inequalities with the same sign can be added together, because both of these inequalities have the greater than sign attached to that, I'll add these together, and then the plus 2x and the minus 2x would cancel off each other. Then what do I have? I have a minus 2y and then a plus 3y, which essentially leaves me with a y, minus 6 plus 4, which leaves me with minus 2. So again, for this question, the answer for this question is choice B. That is, y is greater than minus 2. So essentially, two things that we learned over here. The first thing is inequalities with the same sign can be added together. The second thing is, whenever we have to find the range or the value of one variable out of the two, we always have to eliminate the second variable. That is the process to solve these kind of questions. All right, a very quick pulse check. Are the two solutions that we have just solved clear to all of you? The two solutions that we saw right now, are both of them clear to all of you? That is perfect. Okay, then let's move ahead to question number 3. Slightly more involved, but again, very similar to question number 1, where we saw that like looking terms need to go to the same side of the inequality. So 16x plus 32 and then 48x plus 96. I'll get 48x over here. I'll take 32 over here. So I get 16x minus 48x, that's minus 32x, is greater than 96 minus 32, which is 64. I cancel off, I guess, or rather, we can cancel off in the next step as well. But yeah, minus 32x is greater than 64. Now, I don't have to find the range of minus x. I have to find the range of x. Now, essentially, I can change minus x into an x by multiplying minus 1 to the entire inequality. However, the moment you multiply the entire inequality with a negative number, you have to make sure that the sign of the inequality is changed. That is a very important concept. Whenever an inequality is multiplied with a negative number, the sign of the inequality has to change, right? So then what do I have? I multiply this with minus 1. Then what do I have? I have 32x minus 64, and then you see the greater than inequality sign has now changed into a less than sign. So now 32x is less than minus 64. I divide both the sides by 32. I get x is less than minus 2, which means choice C is the correct answer choice for this question. Okay, now Shantanu has a very interesting question. Can we divide the whole equation by 16? Yes, you can do that. No problems at all, Shantanu. You can do that completely fair. No problems at all. Why do we say infinity here? Isn't x less than minus 2 sufficient? Again, the point over here is the answer choices. If the answer choices are like this, we have to select the answer choice that resonates with the one that we have found out, right? X less than minus 2 means all the values of x which are to the left hand side of minus 2 in the number system. And what is the endpoint? The endpoint is minus infinity here, Nikhil, and that is the reason why we are marking this as the answer. I hope that makes sense. All right then. Okay, perfect. Now let's move on to question number 4. But before moving into the fourth question, very important, whenever you multiply an inequality with a negative number, please make sure you change the sign of the inequality. GMAT tests you on this, and if you do not do this, they have a lot of traps in the questions that they set up in the exam. If you do not remember this, you are surely getting that question incorrect. So please keep this in mind whenever you're solving questions around inequalities and multiplying inequalities with negative numbers. Right? With that, let's move on to the fourth question. The fourth question is the first question where we get into quadratic inequalities. In quadratic inequalities, it's very important that you understand the type of questions that you get. So as you saw over here, we had gotten two questions, right? In quadratic inequalities, we'll get both of that. Why can't we divide by -32? Again, if all the numbers are divisible by 32, you can do that, but I was not sure because I saw 16x as well, right? So that's the reason. Dividing it by -32 essentially means you are dividing it with 32 and then multiplying with -1, right? So it's the same question around. I have a question. If it's given in the question stem x is odd and or even, it means that x is an integer. Yes, that is correct, Pooja. But I'm not very sure where did you get that from. Maybe we can check that in the next set of questions that we have. Okay, so question number 4, the first quadratic inequality question. How do we solve quadratic inequalities? Now understand that this is a number, x minus 2 and x minus 3 are both, let's say, a and b, right? Now, when is the product of two numbers greater than 0? When is the product of two numbers greater than 0? When both are positive or when both are negative. Absolutely correct. So there are two possible cases: when both x minus 2 and x minus 3 are positive, or when both x minus 2 and x minus 3 are negative. Let's talk about the first case. X minus 2 is positive, that means x minus 2 is greater than 0, or that essentially means that x is greater than 2. X minus 3 is greater than 0, which is positive, that essentially means that x is greater than 3. Now if I combine both these two inequalities, if I have to draw a number line, let's say this is 0.2, this is 0.3. Now from the first inequality, I can say that all numbers which are towards the right hand side of 2 are possible values of x. From the second inequality, all numbers which are towards the right hand side of 3 are possible values of x. When I combine both these inequalities, essentially the common portion is from 3 to infinity. So essentially, when I combine both of them, the inequalities return me that x need to be greater than 3 for both these numbers or both these expressions to be to be positive. Now, the second part, very similar to what we have over here. Are we supposed to take the common portion always? Where is the common portion? I'm sorry. Yes, yes, Anmol, correct. Understand this way. If you have 5 chocolates, if you have more than 5 chocolates, if I have more than 6 chocolates, what is the minimum number of chocolates that both of us have individually? Minimum number of chocolates. You try to find out the common region, right? So you see that you have more than 5, so 5, 6, 7, 8 till infinity, all those numbers you have. I have greater than 6, so 6, 7, 7, 8, 9, 10 is all what I have, right? So that's the reason we do this over here. Okay, when both of them are negative, that essentially means that x minus 2 is negative, which tells me that x is less than 2. X minus 3 is negative, that tells me x is less than 3. Again, what is that common region? The common region is when both of the numbers are falling into that region. So you can draw this number line again. This is, let's say, 2, this is 3. At the first inequality gives me this, the second inequality gives me this. So the common region is from 2 to the left hand side. You are saying positive in question, then why are we considering negative cases also? Srinivas, the question mentions that what is that range of x for which the inequality, the product of two numbers, is positive. The product of two numbers can be positive when I multiply two negative numbers as well, right? That is what we are doing over here. I hope that's clear to you. Okay, so now after we get both these, because both of them are possible. It can either be positive, both of them can either be positive, or both of them can either be negative. So both are possible cases, and hence both can be the answer, which means x can belong from minus infinity to 2 and then from 3 to infinity. Tell me, is this question clear to all of you? Ritika, this is how we write inequalities. We do not write or, because both of them are possible, right? So that's how we do it. All right, that is perfect. Let's go to question number 5. And even before going to question number 5, I wanted to, make sure that you learn another process for this question. And this is when we bring in the concept of the wavy line technique. And I'll also, Harsha, if you could please share the wavy line technique, link that we have in one of the web links that's there in Adobe Connect. So Harsha would be sharing that, and in the meantime, what I'll also do is help you understand how to use the wavy line technique, which is a very interesting method to solve quadratic inequalities. Now, the first thing is you need to understand what are the 0 points for this inequality. That means when would these two expressions become equal to 0? So essentially, x minus 2 and x minus 3 are the two equations and inequalities, and Harsha has already given that wavy line link over there. Do not open it right now. You can use that you can use that link after we discuss this question. I don't just want all of you to move back to that web page right now. Okay, so you need to calculate the 0 points. That is, when would these expressions, these partial expressions become 0? So when would x minus 2 become equal to 0? When x is 2. When would x minus 3 become equal to 0? When x is equal to 3. The next thing is you plot both these numbers on the number line. So you plotted 3, you plotted 2. And then you receive 3 regions. There are 3 regions in this number line. The first region is from 3 to infinity. The second region is between 2 and 3. And the third region is from 2 to minus infinity. Right? There are 3 regions. Pick any region that you want to. Let's say I'm picking up the region which is greater than 3 and take a number. Let's say if x is greater than 3, what would happen? X minus 2 would be a positive number. X minus 3 would also be a positive number. So both of them being positive, when I take out their product, results in a positive product. That is something that is the question is asking me, right? So if I'm considering the first region, I am getting to my answer. So this is a region that I can consider for my answer. This is giving me a positive product. According to the wavy line technique, all the regions are alternating in nature. So if the first region is positive, would return me a positive product. The second region, since it's an alternate region, it would give me a negative product. The third region again would give me a positive. If I had a fourth region, it would have given me negative. If I had a fifth region, it would have been given a positive. So the sequence of positive, negative, occurs alternately. You just need to find out one of the regions. The moment it is positive or negative, you can then plot all of the next regions adjacent to it. For example, if you, let's say, took out the region that's between 2 and 3, and if you found out that the product is negative, you can say that the next region is positive, the next to it would be negative, and similarly you can do the same approach. You can take the same approach to the left hand side of this number. The wavy line technique is a fantastic technique to solve questions based out of quadratic inequalities, and I want all of you to keep a little bit more focus. You can click on that web page that Harsha has shared. I don't want you to read through that web page right now. Just bookmark that page. Once the session is over, go to that page and read it out. We also have a couple of questions through which you understand the method completely. Right. So I'll very quickly reiterate. The first thing is you calculate the 0 points and then you plot it in the number line and then consider the regions. Take one region. It's an alternate sequence. You plot the other regions and that's your answer. Right. So I hope the solution and the wavy line technique is clear to all of you. I recommend all of you also to go through that link. Through that, everything would be crystal. Okay, with that, now let me move ahead to question number 5. Now, slightly more convoluted, slightly more, I would say, involved question. Here, I have a fraction. Now, very interesting. If I have a fraction, how do I solve for a fraction, for an inequality where I have a fraction? Now, tell me, I remember the concept of when I multiply a negative number with inequality, the sign of the inequality would change. So can I multiply the inequality that I have over here with an x plus 4, thinking that my denominator would cancel out each other? Can I do that in the chat pod, please? I cannot do that, right? The reason why I cannot do that is very simple. If you multiply an x plus 4, I do not know whether an x plus 4 is a positive number or a negative number. There would be two cases then. I have to either change the sign into a I either have to change the sign if x plus 4 is negative, or I'll have to keep the sign as it is if the number x plus 4 is positive. Since I do not know that, and since I don't want to increase the number of cases over here, I have a secondary option as well, which essentially becomes the primary option in this case, which is I'll multiply the entire expression with x plus 4 whole square. Now, why am I multiplying the entire expression with x plus 4 whole square? Can you people tell me that? Why am I multiplying the entire expression with x plus 4 whole square and not just x plus 4? Absolutely correct, because x plus 4 whole square is a perfect square, and we know that a perfect square is always either equal to 0 or it's a positive number, right? It's never negative. Since it's never negative, I can I don't have to change the inequality sign. So when I do that, what would happen is one x plus 4 would get cancelled off with the denominator. I have x plus 4 times x minus 3 less than 0. What are the 0 points? X plus 4 is equal to 0, means 0 point is minus 4. X minus 3 is equal to 0. That tells me the other 0 point is 3. I plot both these numbers on the number line, and I then use the wavy line method. So I'll take the first region from 3 to infinity. I check if I have any number which is greater than 3. X minus 3 is a positive number, x plus 4 is a positive number. So can I take that number? Can I take that region? I cannot take that region, right? Because it's returning me a positive product. In my original question, I essentially need a negative product. So this cannot be the answer. This would return me a negative product because it's alternating in nature. So this will be my answer. The next region would return me a positive product, which cannot be my answer. So this is also not considered. So hence, at the end, I can say that minus 4 to 3 is that region, which is the answer for this question, which is choice C over here. Now, will it be multiplied by x plus? Yes, it will be multiplied by x plus 4 whole square because it's a perfect square. When I multiply a perfect square with any number, the sign of the inequality need not be changed. Right? And if you just multiply it with x plus 4, the sign of the inequality might be changed as well, depending upon the value of x plus 4. Since I do not know the value of x plus 4, I'll not walk that path. Right? In that case, denominator will be x plus 4 whole square. I'm not very sure I got your point. I'm just multiplying with x plus 4 whole square in the numerator, right? Because whenever I multiply inequality with a positive number, the sign won't change. So it's only in the numerator, not in denominator, numerator both. I hope that makes sense, Abhishek. Okay, so with that, please tell me, is the concept of wavy line technique and the solution to both these questions clear to all of you? Perfect. Multiplying numerator denominator, yes, makes no sense, and that is the reason we would have to multiply the inequality, not both the numerator and the denominator, right? Only the inequality, not both. Can I explain why option D is not correct? Definitely. So there are three regions over here, right? I have a region which is from 3 to infinity. I have the second region from minus 4 to 3, and then the third region, which is minus infinity to 4. Now, in the first region, I'm getting a positive product. In the second, as I told you, it's alternating, so negative product. And in the third, I'm getting a positive product. According to the question, what product am I looking for? I'm looking for a negative product. And that is the reason choice D cannot be the answer. I hope Srinivas, that's clear to you. How can we solve this without the wavy line technique? Again, there would be, if you want to solve this without the wavy line technique, tell me, when is the product of two numbers negative? Valmik, can you please help me with the answer? When is the product of two numbers negative? When one is positive, one is negative, right? Absolutely correct. So you need to approach the question in the approach that we used in question number 4. Do you remember that when we chose two cases? Do people remember that when we chose two cases, Valmik? So you need to approach that question in the same manner. You need to make two cases and then approach the question. Slightly convoluted and lengthy. That's the reason we'll not utilize that method over here. The wavy line technique is very fast. Is it always positive, negative, and positive? Yes, it's always alternating, Mrigakshi. It's always alternating. Can we apply component 1 dividend 2? Again, won't help me over here, Priyanka. Right? Okay, perfect. So let me go to the next question. Question number 6. Question number 6 is when we first talk about absolute numbers, and a lot of students, what I've seen, is struggle with absolute numbers. So what do I have over here? I have an absolute inequality which tells me that modulus of x plus 3 is less than equal to 5. Okay, so how to solve these kind of questions? The best way is substitute whatever there is inside the modular sign. So substitute x plus 3 with, let's say, z. So now what happens? Mod of z becomes less than equal to 5, which tells me that if z is at 0, I can have all values from -5 to 5, right? So this is all the values that I can have. So z can be from -5 to 5, both included. Then I don't have to calculate for z, I have to calculate for x. So I need to replace z with x plus 3. If you replace z with x plus 3, what do I have? I have -5 less than equal to x plus 3 less than equal to 5. And then you subtract 3 from all the three parts of this inequality. So you subtract 3 from -5, from x plus 3, and from 5. What you have? You have -8 less than equal to x less than equal to 2. And lastly, with this, I can answer the question. So for this question, the process to solve these kind of questions is first substitute, then visualize on the number line, and then solve for the variable that's given in the question. How did we find the range of z? I'll explain that. No issue. Can we solve this wavy line? No, we cannot solve. Moin, we can solve quadratic inequalities with wavy line method. We cannot solve this question with the wavy line method, right? If we know the graph of modulus, this can be done too. Yes, it can be. Can we use the process when we have two variables inside absolute value? When we have two variables inside absolute value, becomes a lot more complex questions. Question we will not go into there because going above the scope of GMAT, right? Yeah, the answer is a no. I wouldn't say is a no, but yes, we can definitely create graphs for them. But at the end of the day, yes, we do not have that under the scope of GMAT. But yes, we can create graphs for that as well. Okay, so again, guys, there are a lot of I would say there are a lot of questions in the chat part. Let's first understand this question, and then we'll move on to the next part. In this question, what do we have? We have the value of z to be less than equal to 5. Now, a lot of you asked me, how can I interpret that if the value of z is less than equal to 5, z lies between -5 to +5. Now, I know the modulus value is, when I open the modulus, whatever I have in the right hand side, I can have the values from 0 to that number in the number line, and then from 0 to minus or negative of that number in the number lines, right? Consider this, and let me go to the next slide, which would be much more easier for you to understand. So let's take an example of you and your friend. Let me go to the previous slide. Let's take an example of you and your friend. Let's say you are standing at the coordinate 3. Your friend is standing at the coordinate 5. Can you people tell me what is the distance between both of you? If you are standing at 3, your friend is standing at 5, what's the distance between both of you? It's equal to 2 units, right? And how did you calculate this? How did you calculate 2? You subtracted both these numbers, right? Perfect. You subtracted both these numbers. Next, let's go over here. Consider the two numbers that's present inside the modulus to be the 2 points, right? You subtract the second point from the first point. That is what you did in the previous example. We'll do the same over here. So I would assume that one of the friend is standing at -3. This is where my friend is standing. I am at x. I do not know the value of x, but I know that the distance from me to that friend is less than or equal to 5. The distance from me to that friend, or the distance between me and that friend, is either equal to 5 units or less than 5 units. So then I start thinking, what is that distance through which I can go to 5 units? 5 units from point 3 to the right hand side is still is still 0.2. 5 units from -3 to the left hand side is -8. So then I start thinking that, all right, if my friend is at -3, I can be anywhere from -8 to 2 to be in that range of 5 units or lesser to my friend. Is this clear to all of you? It's a very interesting understanding of how do I use distance to understand absolute value questions. Just in the last question, as you people did 5 minus 3 over here as well, I have a positive sign over here, and I know that I need to calculate the difference between x and y. So y, which is the coordinate of my friend, needs to be -3, so that minus and minus turns this to be a +3, and my position is at x, right? So this is what we did over here as well. So the number on the right side of the inequality is the distance always. Absolutely. So this also tells me, if the inequality, let's say, told you greater than equal to 5, what would you do? Now you start thinking that the distance between me and my friend, tell me in the comment section, the distance between me and my friend is lesser than 5 units or greater than 5 units? If I gave you greater than equal to 5, the distance between me and the friend, is that less than equal to 5 units or greater than equal to 5 units? It's greater than equal to 5 units, right? Because it's mentioned over here that the distance between me and my friend is greater than or equal to 5 units, right? So, the distance concept is very interesting. You can use the concept into solving these questions. It's completely fair. So in that case, what would I have? I'd have everything apart from this inequality, or this range. I'd have everything apart from -8 to 2. Right? And what if mod 5 is on the right side? It won't be. And more, it won't be. Understand, there are infinite ifs and buts, but we need to understand what are the ones that are under the scope of GMAT. Okay, well, so arise as a question, can I say this absolute value is a 3 variable of which 2 values will be given? Yes, you can say that. You can say that. And arise, just let me some moment to breathe, because I have a lot of questions that's there, right? You need to answer all of that. So please give me a moment. I'll definitely answer all the questions that you people have. All right, then, with that, let me move ahead to question number 7. In the 7th question, again, we have mod of p minus q, and the value of mod of p minus q is given as a minus b. Now tell me, what is the minimum value of any modulus number? What is the minimum value of any modulus number? It's equal to 0, right? So a modulus number can never be negative, right? It always has to be 0 or greater than 0, right? So a mod, let's say, which is mod of x, and the value of mod of x is, let's say, y always needs to be equal to 0 or greater than 0. Over here, a minus b, hence, always need to be 0 or equal to greater than 0. So a minus b is greater than equal to 0, which tells me a is greater than equal to minus b over here, and that's the reason choice C is the correct answer. Tell me, is the solution clear to all of you? Very important. The value of a modulus number can never ever be negative. It's either 0 or a positive number. Perfect. That is very good. So with all of the, can you repeat once more? I'll repeat once more, Hemant. Understand, Hemant, I have a modulus sign around a variable, and the value of the variable, the value of the modulus of this number is, let's say, is equal to y. Now, by the definition of modulus, I know that any absolute number can always be equal to 0 or greater than 0. It can never ever be a negative number. So mod of p minus q, which is a modulus number, always returns me a value which is either 0 or greater than 0. So a minus b is either 0 or greater than 0, or that essentially tells me is greater than equal to b. Hemant, I hope it's clear to you. Can you solve this one with the distance method that you did on the last question? Again, this is a different question, right? I can say that I am standing at A and my friend is standing at B because I'm calculating the distance between me who is standing at point P and then Q who is standing at the other friend which is standing at point Q. Here we don't have that inequality, Anmol, and that's the reason we'll not be able to use the same method over this as well. That is correct, Saurav. Perfect. Gaurav, absolutely. The question is asking us to infer, and that is a very important process skill when you are solving questions based out of GMAT algebra. Right. Okay, so we are done with the first 7 questions. I hope the answers for all these questions are perfectly clear to all of you. So P minus Q has no significance in the question? No, it's not that it does not have any significance as such. It's just that P minus Q has a modular sign along with it, and which essentially tells me whatever the value of that expression is, it's always greater than equal to 0. That's the usage of P minus Q over here. Right? And yes, this is a very good way to learn a concept as far as this question is considered. So with that, we'll now move on to the next stage where we would discuss process skills, and just allow me a moment. I would give you the poll for the first question. I hope all of you have already saved out the link for the Wavy line. After the session is done, I'd recommend all of you to go and check that poll out. Okay, just allow me a moment. Let me get the poll over here. And the first questions are essentially questions which have 4 option choices only. So I'll get your poll which contains only 4 option choices. Just give me a moment. I have the poll. I'll open the poll. I'll recommend all of you to please mark as still solving. Can A and B both be positive or negative integers? A and B can be anything, as far as you just need to be cognizant of the constraints that are there in the question. That's it. All right, I am not seeing still solvings. Guys, please, let's do that. I hope you have not forgotten the process. The moment I have 60 people mark as still solving, I'll give you the first question. And remember, these questions are very, very interesting, would require all the learnings that we had from the previous set of questions. I only have 42 responses. I need 60 people, so I need 18 more people to mark as still solving. Please do that. For these ones, we'll discuss the explanation right then and there, Ritika. Right? So let's move into the first question. All the best for this one. All right, very interesting. Last 10 seconds to mark the answer for this question. Please mark your answers in the poll. Last 10 seconds only. Five, four, three, two, and one. So I'm going to end the poll and broadcast the results. 37% if you have marked choice B. 27% of you, as you can see, have marked choice C. 13% go with choices A and D respectively. The difficulty level of this question would be somewhere around 650 to 680, right? It's not a that difficult question, but there are certain number of pointers which if you do not recognize, the chances of getting this question incorrect is very, very high. And I'm going to talk about those pointers right now before we go into solving this question. Now, every one of you, I hope all of you have read the question. How many non-negative integral values of m do I do the two equations satisfy? So I need to calculate non-negative integral value. Can you people tell me what is the smallest non-negative integer in our number system? What's the smallest non-negative integer? Absolutely correct. Now, for people who mark 1, understand there's 0 as well. 0 is the smallest non-negative integer. 1 is the smallest positive integer. And -1 is definitely not the smallest negative integer, right? Guys, what is the smallest negative integer? Don't tell me -1. Yes, it has to be minus infinity. No, -1 is the largest negative integer, Abhishek. -1 is the largest negative integer, right? Okay, so let's get back into the question and solve this question out. Now over here, what do I have? I need to calculate the values of m. Now if I have to calculate the values of m, what do I need to eliminate? Which is that variable that I need to eliminate? I need to eliminate n, right? So I have a minus n, I have a plus n. I can see that if I get a chance to add both these inequalities, the n would cancel out each other. So let's go to the next step. Now, tell me, what all values can m take out of these 4 answers? What all values can m take out of these 4 answers? 3? Absolutely correct. Yes, 3 is absolutely correct. Let's move ahead. They have to be non-negative. Keep this constraint in mind. If I add both these inequalities up, right? I have 2 inequalities with the same sign. If I add both these inequalities up, the minus n would cancel off the positive n. And what do I have? I have a minus 4m and then a plus 10. Now, if the plus 10 is taken to the right-hand side, it becomes a minus 10. So minus 4m is greater than minus 10. Now, what do? I need to calculate the value of m. So I need to multiply this entire inequality with minus 1. So that minus 4m turns into plus 4m. Also, if I multiply it with a negative number, the sign of the inequality would change. So the greater than sign now becomes a less than sign, which represents minus 4m is less than 10. When I divide both these inequality expressions by 4, or both these sides by 4, I get m is less than 2.5. Now, if m is less than 2.5, and you also had mentioned that m needs to be greater than or equal to 0, what are the values that m can take? 0, 1, and 2. So there are 3 possible values that n can take. Hence, choice C becomes the correct answer choice for this question. Now, people who had marked choice B, where did you falter? People who marked choice B, where did you falter? And I essentially know where did you falter. I just want all of you to tell me what was that reason of faltering. Yes, you did not consider 0. You forgot that 0 is a non-negative integer. One very important area which GMAT would test you. And if you forget this, even after spending those 2 minutes, getting that answer correct becomes so very difficult just because you missed one very small constraint. But I hope after this, you would not make the same mistake again, right? So with that, we'll move on to the next question, but please make sure that you keep an eye on the constraints, because if you do not do that, even if you put in your honest efforts to solving that question, it becomes difficult, right? So Maya also forgot to reverse the greater than sign into a less than sign. Again, something that a lot of students falter in. Whenever you're multiplying a negative number, please make sure you do that, right? It's an easy question, but it has two, three, those tricks attached to it, or two, three areas where the student faltering is very high. The chance of that is very high. That is what makes it a difficult question. Right. Okay. So with that, let's move on to question number 2. Let me get all of you the poll for this question and reopen the poll. Okay. Can you please mark a still solving? And I need 60 people to mark a still solving before I give you the next question. So please do so very quickly. All right. Let me go to question number 2 on your screen. All the best for this one. All right. Last 3 seconds to mark the answer. Last 3 seconds to mark the answer for this question. 2, 1, and 0. So I'm going to end the poll. And before I, publish the answer, broadcast the answer, I want every one of you, and I literally mean that. I want every one of you to read the question one more time. Just the question. I hope it's done. Okay. Now, come to the options. Tell me, which are those options which can never ever be the answer? You don't have to solve, you can just say that after reading the question. Which are those options which can never ever be the answer? A and C, absolutely correct. Because A and C are not, they are not, what are they not? Yes, they are not integers. And over here, it's specifically mentioned that x needs to be an integral number. With this, can you people predict the percentage of people who have marked choice A as the answer? Take a wild guess. 20, 15, 0. No, it's never 0, Srikanth. Very interesting. Math 3 being the closest. So essentially, let me broadcast the results. 44% of you have marked choice A as the answer. Now tell me, do you people have any difficulties in comprehending the question and solving that out? Not at all. Then why did you get this question wrong? Only because you did not pay attention to this part of this question. I would never ever call it a silly mistake. It's a very, very big blunder. The reason of me calling this a blunder versus a silly mistake is very simple. If you call this a silly mistake, and if you, use the term silly over here, you'd keep on making the same mistake over and over again. You'd not, give a lot of attention to this. So please make sure you read the question properly, something that we learned in the previous question itself. We have to read the question stem properly. Okay, with that, let me move on to how to prevent these mistakes, to make sure you are not thinking anything while you are reading the question and you read each word properly. That's it. And the moment you find a constraint, write that down in the notebook. The moment you see that integer x, write that down, that x is an integer in the notebook where you're solving the question. That's how to go about it. Okay, now let's very quickly come to the question and see the solution to it. I have two inequalities. I need to find out the value of x. So let's see. The first inequality, I have 16x plus 32 to be greater than 48x plus 96, something that we previously had solved. And then I have 17 plus 3x to be greater than equal to x plus 6. So what I do is I solve both these inequalities. From the first inequality, I get that the value of x is less than 2. From the second inequality, I get the value of x is greater than equal to minus 5.5. So I plot what are the possible cases that are there. So x can take all possible values from minus 5.5 to minus 2. I need to find the minimum value. So the minimum value could have been minus 5.5. However, it's given that x needs to be an integer. So what's the next integral value to minus 5.5? It's minus 5, and that is the answer for this question. So the answer for this question is choice B. Is the solution clear to all of you? And everyone who marked choice A, is it clear to you as well? Perfect. And with these learnings, we'll move into the next question. The point over here is I want you people to read the question properly. Please, let's do it. If we solve it by adding both equations, we get minus 2 as the answer. No, we are not adding both these equations, right? We need to find the minimum value of x which satisfies both these equations, right? So I need to find x which satisfies this and satisfies this. So that's what we are doing over here, Mohit. And sir is not required, just Atra is fine, please. Okay. Can we add both equations as we did in previous? We can do that, but if we add both equations, understand, is it bringing us any good? It's not, right? we essentially have to do what? We have to find the value of x that satisfies both the equations. If I add both of them, then I'm converting two equations for one. That is not possible. Why should give the same, why does the sign not change from 5.5? So what you do over here is you have 3x, you have x, you take this x over here, you get 2x, and then you have plus 6, you take minus 17 over here, 17 over here, get minus 11. So 2x is greater than equal to minus 11, or x is greater than equal to minus 5.5. I hope that's clear to you, shall we? Absolutely. This tells you why is it quantitative reasoning and not simply a math test. Absolutely spot on, Anmol. Okay, so that is good. Let's move on to question number 3, and just allow me a moment. So over here as well, constraints are very, very important. Right? So we will now move ahead with question number 3. And just allow me a moment. I have reopened the poll. Can you please mark us still solving? Srinivas, we concluded option B because x needs to be greater than 5.5. So the smallest integer which is greater than 5.5 is minus 5.5 is minus 5. That's the reason B was the answer. Okay, that is perfect. Question number 3 on your screen. All the best for this one. All right, the last 10 seconds. Please put your answers in the chat. Please put your answers in the poll, not in the chat pod, guys. Let's please follow this. Last 10 seconds. Please mark your answer in the poll if you have not marked it yet. Three, 2, and 1. I'm going to end the poll and let me not broadcast the results as of now because I have a follow-up question as well. So let me bring up the poll over here and give you a new poll because I have a follow-up question and I want you to answer that question as well. Guys, please let's make sure that we do not put the answers in the chartboard. We don't need to do that because I'm giving you polls, right? So let's make sure that we don't put your answers in the chartboard. It really affects the other people's answers as well. So please mark us still solving, guys, very, very quickly. Let me give you the question next to it. Sushil, you just mark, you just need to click on that button that you can see before the poll. It's very simple. Okay, question number 4 on your screen. All the best for this one. All right, 5 seconds to mark the answer over here. 5 seconds. If you have not marked it, please do so. 3, 2, and 1. I am going to end the poll. Okay, so let's move into this third question and let's discuss this question. It's a very interesting question. And let me also bring up the poll for this question because we are going to discuss this. Okay, now I want all of you to read the question once. Something that we did in the last question. Let's do it for this one as well. Can we please read the question once? And after you're done, please write it down in the chartboard so that I know you are done reading the question. Okay, that is very good. Now, let's come back into this question and let's see. What is the range of the values of these? So in the question, I need to find out the values, the range of what? I need to find out the range of what? Z square, right? Okay. Is Z square a positive? Is Z square a perfect square? Is Z square a perfect square? Okay, you people tell me that Z square is a perfect square. Perfect. Z square is not a perfect square? No, Z square is a perfect square over here. It's a perfect square. I understand. You might be thinking, what if Z is equal to an imaginary number? No, that is not going to happen. Imaginary numbers are not under the scope of GMAT. These are real numbers. It's a perfect square. The perfect square of any real number is never negative, right? Okay, now Z square, what is the minimum value of Z square? What is the minimum value for Z square? It's equal to 0, perfect. In a yes or no, please, can Z square be negative at any point in time? Okay, you people tell me no. That's very interesting. So can you people tell me which of the options can never ever be the answer? You don't even have to solve the question, but right from the definition of Z square, which ones can never be the answer? Which of the options? People say A, C, and E. A, C, and E, perfect. Why A, C, and E? Because A, C, and E include those negative parts into their answers which can never be true. So the answer is either B or D. Now, can you people guess how many students marked as a percentage? How many students marked choice A? Guess this out. How many percentage of students marked choice A? Ah, interesting. Because 43% of you have marked choice A. 43% of you have marked choice A. Now, everyone tell me, people who have marked choice A, did you even consider the fact that z square can never ever be negative? So even after, solving out the question, you got it wrong, right? Because I forgot one very simple constraint. Could you please explain why z square has to be a perfect square here? Uh, okay, why would z square not be a perfect square, Anmol? Let me ask this counter question to you. Why would z square not be a perfect square? What if it's root 2? But over here, even if it's root 2, z square is a perfect square, which is 2. Is z square a negative? We're not talking about integral numbers here, that z is an integral number. There's a difference between an integer square and a perfect square. A perfect square essentially means it's the square of a number. That's it. It's a square of a number. A number can be negative and positive, or positive. It's completely okay. But it is a perfect square or a whole square, whatever you call it, it's completely okay, right? It's still not, definitely not negative, right? It's definitely not negative. It's either equal to 0 or greater than 0. Okay, now that I know that z square is equal to 0 or greater than equal to 0, I have two expressions, z square plus 4 and z square minus 2. Now tell me, can z square plus 4 be ever be a negative number at any point in time? Can z square plus 4 be negative at any point in time? Yeah, z can be negative, Stella, not a problem at all. But z square is always positive, right? Over here, I need to find the range of z square, not z, right? Please understand the difference. Okay, so z square plus 4 can never ever be negative because z square is a positive number or equal to 0, and I have a positive number with it. So the sum is always greater than equal to 4. Okay, however, when is the product of two numbers less than 0? When is the product of two numbers negative? Tell me, when is the product of two numbers negative? When one is positive, the other is negative. And we inferred that z square plus 4 can never be negative. So it is a positive number. That essentially tells me that z square minus 2 is a negative number. Is this clear to all of you? Z square minus 2 has to be a negative number because z square plus 4 is always positive in nature. Right? Now, since z square minus 2 has to be a negative number, z square has to be less than 2. And I know that the minimum value that z square can take, since it's a square value, is equal to 0. So z square can lie from 0 to 2. And option D, which 15% of you had marked, is the correct answer choice for this question. Now tell me, is the solution clear to all of you? It's a wonderful question. It's a question where the question setter tries to trick you in so many different points. Right? And if you got this question correct, I'm very, very happy. 3 and 4 are really fun to solve. Just wait a more. Just give me another 2 minutes. AK, just give me another 2 minutes. Difficulty level for this question, I would say somewhere around 680 to 700. 680 to 700 is what I would rate it. Can you explain why it's D and not B? Okay, very interesting. I know that z square minus 2 is a negative number. Can it be equal to 0? If it's equal to 0, the inequality would be less than equal to and not only less than, right? That's the reason z square is less than 2 and not less than equal to 2, right, Hemant? And that's the reason it's not choice B, but choice D. Perfect? Perfect. All right, that is very good. Sushil, when I go for the poll showing this is yes, yes, yes. To view this content, switch to web browser. Okay. I I don't know if you're saying this to me or someone else, but okay, that's good. Mohit, can you repeat the solution? I'll definitely repeat it once. Mohit, when is the product of two numbers negative? When one of them is positive, the other is negative. Over here, this is a positive number because z squared is equal to 0 or greater than 0. I'm adding 4 to it, so this can never be negative. So z squared minus 2 has to be negative, and since z squared minus 2 is less than 0, which is negative, z squared lies from 0 to 2. I hope Mohit, it's clear to you. Okay, perfect. Let me go to question number 4. Now, what did the fourth question ask me? Guys, what did the fourth question ask me? If z is an integer, how many values of z square satisfies the equation, right? If z is an integer, how many, Mohit, can you please put that question in the Q&A pod? Harsha would help you answer that question. Okay, if z is an integer, how many values of z square satisfies the inequality? Now, very nicely understand. I had the value of z square from 0 to 2, right? Now, if the values of z square is from 0 to 2, and if z is an integer, what are the possible values that z square can take? It can either be 0 or 1. Now, how many of you thought that z can be minus 1 as well? How many of you thought this? Write a me in the chat pod. How many of you thought that z can be minus 1 as well? Because I'm very, very sure there would be a lot of people. And the reason you thought that is, do you know the reason why you thought that? The reason is you thought that you need to mark z, you forgot that you are trying to find out the values of z square, and z square can never be minus 1. Again, a very interesting question, a very simple question at the end of the day, but it has so many areas of faltering. It makes this question so nice for us. Okay, very quickly, is the solution clear to all of you? So the answer choice for this question is 2, which is 0 and 1. That's it. Mrigakshi, can you please help me out answering where is the issue, please? Why is it not minus 1? Mrigakshi, are we finding the value of z or z square, Mrigakshi? Are we finding the value of z or we are finding the value of z square? Read the question again, please, Mrigakshi. Once more for me, please. And then tell me, got it? Perfect. Z can be minus 1, absolutely correct, but z square cannot be minus 1, right? Very good pointed out, Hemant. Yes, absolutely correct. Okay, now we'll move on to question number, and just allow me a moment, please. We'll move on to the next set of questions, and these questions are really very interesting. So till this point in time, we were solving questions based out of process skills, and we were using constraints, inference, and all of this to solve these questions. It's very important that you understand process skills better. Now, in our course, what we have is we have dedicated files to make sure that a student understands constraints better, understands how to infer better, understands how to manipulate better, so that all these mistakes that you're making, you stop making those mistakes, right? All the process skill files that are there in the course help you learn this. We have that in linear equations, we have that in quadratic inequalities, we have that in absolute values, in all modules that are there in GMAT Quant. Right, so let's now get into those much more difficult questions. I will clear all the answers over here, bring in the poll for all of you and reopen the poll. Please mark a still solving. And this is where the fun begins. Yes, we will be doing DS questions. How long will the session go on? Give me another 30 minutes. We have 3 more questions, 3 very interesting questions to solve. Right, I have my still solvings here. Let's go to question number 1 over here. All the best for this one. All right, last 3 seconds to mark the answer for this question. 3, 2, and 1. Let me end the poll. So let's see what we have gotten over here. 24% of you tell me that the answer for this question is choice B. 24 tell me it's choice C. So guys, tell me, how was this question? This is it's written over here, Gaurav. It's a 700 plus, right? Right. Too many equations, right? Too many equations. Did require careful reading. I am so very happy to see that ahead because every question requires that. If you miss a constraint, that becomes a problem, right? So let's move into the question. X and Y are positive integers such that I have one inequality, I have another inequality. I need to find out what is the positive difference between the minimum possible value of X and the minimum possible value of Y. So after I get the minimum possible values of X and Y, I need to calculate the difference between those two numbers. So let's move back into the question and solve this question out. So I have two inequalities. I know that X plus 2Y is greater than 20. I know that 3X minus 30 is less than minus Y. Okay, so let's look at the first inequality. What I'll do is I'll take the 20 that I have into the left hand side, and that becomes my first inequality. X plus 2y minus 20 is equal to 0. And then what I do for the second inequality is, again I'll do the same thing. I'll take the y to the left hand side, and then what do I get? I get 3x plus y minus 30 to be less than 0. And then what do? I do a minus 1 with all these numbers, and I then change the inequality sign. So I have a minus 3x minus y plus 30 to be equal to greater than 0. This is my second inequality, right? Now that I have the second inequality and the first, the intention over here is to get to the values of x and y. So once I have to eliminate x, one time I have to eliminate y to get the values of y and x respectively. Okay, so what do I do is I multiply the first inequality with 3. And why do I do that? I am seeing that I have a minus 3 over here. If I can convert this 3 into a plus 3x over here, I can get to the value of y because x would get eliminated. So 3x plus 6y minus 60 is greater than 0. I know that minus 3x plus y plus 30 is greater than 0. I add up both these up, and what do I get? I get the value of y to be greater than 6. If the value of y is greater than 6, the minimum value of y is equal to 7. Tell me, is the solution clear till this point? Every one of you, is the solution clear till this point? So should the inequalities be the same in both equations to proceed finding the solution? Not necessarily. The sign can change as well. No problems over here. Why is it y minus x and not x minus y? Let's not go over there, JA. We're still not there at the moment. We're there till the time that we have found the value of y. Let's stick to it. I'll explain that. Do not worry. Okay. Now that that we have the value of y, we now need to find out the value of x, right? Now I know that minus 3x plus 24 is greater than 0. Now how do I get that? I know that y minus 6 is greater than 0. If I add this inequality with this one, the y cancels off each other, and I then get minus 3x plus 30 minus 6, which is plus 24 greater than 0, which tells me that x is less than 8. If x is less than 8 and x is also a positive integer, what is the minimum possible value of x, guys? What is the minimum possible value of x? Now, how many of you, it's equal to 1, right? It's equal to 1. Now, how many of you took x to be equal to 7? Tell me this. How many of you took x to be equal to 7? Yes, there would be some people, right? There would be some people. Is 0 not positive? No, 0 is non-negative. The first positive integer is equal to 1, Priyanka. right? So the value of x is less than 8, but I need to find the minimum value of x, which is equal to 1. This is the smallest positive integral value in our number system. Okay, now that we have this, what is my next step? My next step is to find out the difference. Can I repeat the process for x? I'll repeat the process of x. Wait. So what do I have over here, Hemant? I have x, y minus 6 is greater than 0, right? Let me write it down over here. Y minus 6 is greater than 0. I have minus 3x minus y plus 30 to be greater than 0. I'll add both these up. I have minus y plus y, which cancels out each other. I have plus 30 minus 6, which becomes 24. I have minus 3x. So minus 3x plus 24, from where I get x less than 8. Is this clear, Hemant? Please check. Very quickly, please. Perfect. Okay, I have a question from Sushil. Why can x not be 0? Sushil, can you please read this statement? X and y are positive integer. Sushil, tell me, what is the smallest positive integer in our number system? What's the smallest positive integer in our number system? Positive integer. It's equal to 1, absolutely, right? That's the reason. Okay, so the value of x is equal to 1. That's the minimum value. The value of y is equal to 7, right? Okay, if the value of y is equal to 7 and the value of x, we need to find the positive difference. The meaning of positive difference is, so you can calculate it two ways, 1 minus 7 and 7 minus 1. I need to calculate the positive difference. So this is my positive difference, because this leads to minus 6, which is not a positive difference. That's the reason. That's the reason this is the answer for the answer for this question is equal to 6. Okay, Google says 0 is an integer. Yes, 0 is an integer, but just Google it. Is 0 a positive integer, GA? 0 is definitely an integer, but not a positive integer. Please understand the difference. Perfect. What if y is greater than 12? We'll not go into that, please. There are infinite ifs and buts, but let's not go into that, please. What is the benefit of putting both the inequalities set to 0? The reason behind that is, if both the inequalities are set to 0 and both have a positive greater than sign, I can then start utilizing them in terms of adding inequalities, right, Raish? As we discussed, we can add inequalities with the same sign. So that was the entire essence of what we had done over here. Over here, this is not essentially 3 and 4. This is essentially 3 and 2. Not 3 and 4, but 3 and 2. I hope that's clear. What if we multiply by minus 3? You can multiply by minus 3 as well, no problems. You can multiply the first equation with minus 3. That would also work. No problems. Right? Okay, with that, let us move on to the next question. In the previous question, did we not consider 0? Did that question imply integer not positive? Yes, please. Okay, since you have a lot of questions around this, please understand 0 is non-negative in nature. 0 is the least or the smallest non-negative integer. 1 is positive and the smallest positive integer, right? Please let's understand the difference between these two. Do we have any other benefit besides this one? No, no other benefit besides this one. It's just, it helps understanding and adding up inequalities. That's the reason we did it arise at the first place. Okay, so with that, let me clear all the answers from the poll. Can you please mark us still solving? I'll bring up the first DS question to all of you. I am very sorry. Let me reopen the poll. Please mark us still solving right now. You have the poll open. Understood. But can we keep the value on both left and right? You can, but that again makes us a little bit difficult. That makes it a bit difficult. Again, you can completely do that. Not an issue at all with that. Right? Okay, perfect. Question number 2 on your screen. But before I move into question number 2, 3-4 very important things. How to approach a DS question. Make sure that you go you do a thorough question statement analysis before you move into the point that you start analyzing the statements, right? It's very, very important that you understand what is the question stem asking, or giving that an implicit information to you. Once that is done, once the analysis of the question statement is done, only then you move on to statement one, right? If you can solve the answer, you can eliminate choices B, C, and E. If you cannot solve the answer with statement one, you can eliminate A and D. Then completely forget about statement one, move on to statement two. If you cannot solve the question with statements one or two, only then utilize both the informations. And if you can solve, mark C. If you cannot, mark E. Good to go? Mark a yes in the chat pod, please, if you are good to go with this. And I would bring in the first DS question to all of you. That is perfect. Okay, the first DS question, all the best for this one. All right, then. Last 3 seconds to mark your answer. This tells me it's a slightly difficult question, isn't it? Okay, so I'm going to end the poll and broadcast the results. 38% if you tell me that the answer for this question is choice C. 23% of you tell me it's choice A, 12 go with choices B and E, and 6 with choice D. Perfect. Let's move into the solution to solve this question. But before that, tell me, did you people find this question difficult? Let's see, what do you answer? It is essentially a difficult question, very honestly. Again, understand it's a 700 plus DS question, so it has to be slightly difficult, right? But not that difficult. It's definitely not very easy. If you find this question very easy, your quant prep is perfectly going in the right direction. Okay, so let's solve this question. So over here, what do I have? I have that z is an integer, and mod of z is less than 6. Now, if mod of z is less than 6, that z can take the values, and since z is an integer, the values that z can take is from -5 to +5, which is a total of 11 possible values. Now, how many of you did this? Before moving into the first statement, how many of you did this? Okay, if you did, well and good. I'm very happy for these people who did this. If you did not do this, it is going to be slightly difficult when you move on to the first and the second statement. And how would that be difficult? I'll show it to you in another moment's time, right? So what am I doing over here? Before moving into the question statement, the statement 1 or statement 2, I am analyzing any information that the question stem provides me with, right? So z can range from -5 to +5 are the numbers that the question stem is telling us. Let's move into the first statement. The first statement tells me that mod of z minus 2 is greater than 3. Now, if mod of z minus 2 is greater than 3, either z is greater than 5 or z is less than -1. How did we get to this point? If this is greater than 3, the number either has to be greater than 3 or less than -3. Only then a number which is less than -3, for example, let's say -4, -5, -6, and all of those numbers, mod of those numbers would be greater than 3, right? Hence, I see that from here, z is greater than 5. From here, z is less than -1. Till this part, is the solution clear to all of you? Perfect. That is very good. Now, if you had not done the initial analysis, we would have faltered over here. From this part, you can say that z is both positive and negative, yes or no? Only from this part, you can say that z is both positive and negative, yes or no, right? But this is incorrect. Why? Because I know that the values that z can take are from -5 and are from -5 to +5. Now, are there any number which is greater than 5 and belong to this region? Is there any such number which is greater than 5 and it belongs to this region that we had from the question statement? Please tell me in a yes or no, please. Is there any number which is greater than 5 belonging to the range? There is no such number. So z cannot be positive. If z cannot be positive, can z be negative? Let's check that. Is there any number where z is less than -1 which satisfies these conditions or this range? Yes, there are. I have -5, I have -4, I have -3, I have -2. So essentially, I have 4 such numbers, and all of these 4 numbers are negative, which tells me the first statement is sufficient because I can answer if z is positive or not. Is this analysis of the first statement clear to all of you, and the importance that the analysis of the question stem brings to the statements analysis? If you had not done the statement question stem analysis, this would have been impossible, right? And through these questions, we try to teach you why is it so very important to ensure that you do a proper and thorough question stem analysis before you move in to the statement, to the first and the second statement. That being said, now that we see, so will we not even check B? We will check B. But as of now, we know that statement 1 is sufficient. Let's move on to statement 2. Statement 2 tells me that mod of z is equal to 2. Now, if mod of z is equal to 2, I know that z can have two values. It can either be plus of 2 or it can be minus of 2. So z can either be positive or be negative. Can I answer whether z is positive or not? Can I answer through the second statement whether z is positive or not? We cannot answer it because I'm getting two different answers, yes and no both, right? Hence, statement 2 is not sufficient. So statement 1 is sufficient, statement 2 is not. The correct answer choice is choice A. Absolute value is never negative. No, absolute value is never negative. But over here, we are talking about something else. We're talking about is z positive? It's a yes or no question, Priyanka, right? We can say that no, z is not positive, right? We're not getting to the values of z. We're just saying whether z is positive or not. It's a yes or no question, right? Okay, is the solution for this question clear to all of you? Very interesting question. Very, very interesting question, trust me. 10 seconds to solve this question is very nice. Anmol chose A, but with the wrong reasons. I just hope that you now got why A is the answer. So we can say that z minus 2, right? I'm sorry. Z is equal to 2. Z cannot be equal to 2. Z can be 2 and minus 2 both. And both of these numbers come in the range of minus 5 to plus 5. Right? And that's the reason we cannot say whether z is a positive or a negative number. Please understand the difference. The A part, I'll do that. From the A part, I hope all of you were clear till this point that z can either be greater than 5 or z can be less than minus 1. Now, from the question statement did tell us that, right, that z can take all these values, which is from minus 5 to plus 5. Z can take all these numbers. Okay, if z can take all these numbers, then which is that number from minus 5 to plus 5 which is greater than 5? There is no such number. So z cannot be positive. Which is that number which is less than minus 1 and is between minus 5 and plus 5? There are four such numbers from minus 5 to minus 2. Right? And hence, since all of these numbers are negative, I can say that no, z is not positive. And since I can answer the question, statement 1 is sufficient. If we consider that absolute value is non-negative, can z be 2? Yes, z can be 2. If we consider that absolute value is non-negative, but z can be minus 2 as well because mod of z is equal to 2. Why did you take z minus 2 to be less than minus 3? Srinivas, good question. So understand, there are two regions, right? Any number which is lesser than minus 3, mod of that number would always be greater than 3. That's the reason I wrote this over here. Again, the question is about z, not mod of z, so please understand the difference as Harsha has pointed out. So please understand that difference. So I hope the solution for this question is clear to all of you. With that, we'll move on to the next question. The next question is also very, very interesting. Let me clear all the answers, bring in the poll, reopen the poll so that you people can mark us still solving. And then let's move on to the second data sufficiency question. All right, question number 3 on your screen. All the best for this one. All right, last 10 seconds to mark the answer for this question. If you've not done it, please do so. And you mark the answer. Oh, you don't mark the answer in the chat pod, Anna, please. In the poll, please. Okay, 3, 2, and 1. Let me end the poll and broadcast the results. 27% of you tell me that the answer for this question is choice A, 33% of you tell me it's choice D, 18 go with choice B, and 8% with choices C and E both. So let's discuss the solution for this question. Now in this question, it's given, it's asked whether A is less than B or not. So I don't have a lot of information. I would say we don't have any information as far as the question statement is considered. And then since we do not have any information over here to extract, we would go directly into the first statement. The first statement tells me that mod of A minus B is equal to B minus A. Now, what can you say about B minus A? Tell me in the chart pod. What can you say about B minus A? What can you infer about B minus A? Absolutely correct. It's either 0 or greater than 0, right? It's either 0 or greater than 0. Absolutely correct. So choice 3 is absolutely correct. Now, since B minus A is greater than equal to 0, that essentially tells me that B is greater than equal to A. So there are two possibilities, right? There are two possibilities. One is A equal to B. The other is B is greater than A, or essentially means that A is less than B. The absolute value, whenever we have a modulus of some number, it's always either equal to 0 or greater than 0, Stella, right? That is where the definition of modulus is coming from. The value of a mod of a number is always equal to 0 or greater than 0, right? So there are two possibilities. Now, can I answer whether A is less than B with this? I cannot, because A is either equal to B or less than B. So I cannot answer the question, and that is the reason the first statement is not a sufficient statement to answer this question. Tell me, is the solution till this point clear to all of you? Is the solution till this point clear to all of you? That is very good. That is very good. Now we'll move on to the second statement's analysis. What does the second statement tell us? Srish, can you please tell me what was your issue? What did you not understand? Very quickly, please. What could we not understand over here? Why A is equal to B? Because the modulus value can also be equal to 0, right? That's what we discussed. Mod of A, if that is equal to B, B can always be greater than 0, or B can also be equal to 0. Right? And look at the comment that Harsha has posted. That should take care of all of this. But also on that same note, Trish, it tells me that the concepts on modulus is slightly on the south side. We have to go through the concept files to make sure we completely understand the topic, right? So we'll do that post the session. Non-negative, but equal to 0 or positive. If you are struggling to understand the definition of modulus, Stella, I would recommend you going through the files in your free account. You can just log into your account and all of that would be available to you. Right? If you have any questions, you can drop us a mail as well. Okay, so let's now move into the second statement. The second statement tells me A by B is less than 1. Now, if I multiply B to both the sides of this inequality, I can write that A is less than B. However, I do not know whether B is greater than 0 or less than 0. There are two possible cases. If B is positive, then I don't have to change the sign of the inequality, right? Since I'm multiplying both the sides of the inequality with a positive number. However, if B is negative, then the sign of the inequality would change. So the less than symbol now becomes the greater than symbol. So there are two possibilities. A can be less than B, A can be greater than B, depending upon what is the value of B. Since I have two possibilities, again over here, I cannot answer this question. So the second statement is not a sufficient statement to answer this question. With this information, we'll move on to the next step, which is combining both the information from these two statements. From the first statement, we found out that A is either equal to B or A is less than B. From the second statement, we found out A is less than B or A is greater than B. So which is that common part that we have over here? The common part is A is less than B, since we can answer the question after using both the information from statement 1 and statement 2. Hence, the correct answer choice for this question becomes choice C. Right? I hope the solution is clear to all of you. But please tell me if you have any concerns or questions over here. I see a lot of questions, so let me just pull this up over here and expand this so that I don't miss any. Can't we say since A by B is less than 1, denominator is positive than the... No, we cannot say that, sort of. I'm very sorry. Consider two negative fractions as well. We cannot say that. What if A and B are both negative? No, we are not going to that part, Thomas, right? So we're not discussing about A. We are multiplying a negative number. When we multiply a negative number, only then the sign of inequality changes. We are multiplying the number with B, and since we do not know the value of B, whether it's positive or negative, that's the reason we don't want to get into A. We just are around B. So understand, I have A by B to be less than 1. Right? This is the statement. If I multiply B with both the sides, what do I have? I have A to be less than B. Now I have just multiplied with B. I do not know whether B is positive or negative. If it's positive, the sign of the inequality won't change. If it's negative, the sign of the inequality will change. I hope this is now clear. Stella, I hope this is clear. I hope, Priyanka, this is clear. We did discuss, right, that with the sign of B, if we multiply a negative number with an inequality, the sign changes. We did discuss in the warm-up questions. So I would recommend you revising that part once more once you get the recording. When we multiply a negative number to an inequality, the sign of the inequality has to change. Yes, it becomes A greater than B, correct. It doesn't become minus A greater than B. It just becomes A greater than B because B is a negative number over here. I'm not multiplying A. I'm just changing the sign over here, right? We're not getting into that part. Okay, notice that we have two variables inside the absolute values. I guess you meant GMAT won't ask you calculate A and B where, yes, that is correct. That is correct, Arise. But we multiply both sides with B squared, then we can't infer A. See, you can also multiply with B squared, but again, that would not lead us to any value. We then have to take a common number and then solve it out. Lengthy process, but not getting into that. Right? Okay, so with that, I hope the solution for this question is clear. Again, very interesting question. The things that we take home from this question is A, if you multiply a negative number with the inequality, the sign of the inequality needs to change. B, modulus of any number is either equal to 0 or greater than 0. It can never ever be a negative number. With that, I hope the solutions for all these questions are clear to all of you. Okay, like we discussed, can't we multiply both sides with B squared? You can multiply both sides with B squared. So post that, what are we left with? We are left with A times B is less than B squared. Now, what do you have? Again, over here, you have what? If it's less than B squared is a positive number, right? So A times B is less than a positive number. This gets to much more difficult roots, right? And that's the reason we are not multiplying this with a B square, but we are multiplying with a B because dependent upon the value of B, my value of A I would get the value of A with respect to the value of B. Hope that's correct and clear to you. Yes, if B is negative, then A becomes greater than B. Perfect. That's correct, J. That's correct. Okay, so with that, I would now move on to the next part, and I hope all of you have solved a lot of questions. So just allow me a moment over here. Let me go to slide number 79. Perfect. So now that you have solved so many questions, tell me, what does it take to score a Q50? And let's see some answers over here. We have learned a lot in today's session, right? And you have made mistakes and also learned from them. And making mistakes is completely fine. Presence of mind, absolutely true. Practice, I won't say a lot of practice needed, but yes, concepts very good. Constraints, absolutely correct. Reading the question statement clearly and with clarity, yes, very good. Attention to detail, attention to the question statement. That is correct. Precision would come when you follow all of these sort of. That's an output, I would say, right? So essentially, what we have found out is there are three things, that which are important for you to score a Q50 or higher, which is A, you need to have a very good clarity over the concepts. You need to understand the process skills to solve questions, and third, you need to understand GMAT skills, which is what are those extra features that you need to inculcate to solve difficult questions of that 700 level questions that you see. All these things are completely covered in the course that we have over here. Now, there are process skill files that help you understand how to solve process skills. There are GMAT skill files to understand how to get a hold of those skills to solve difficult level questions. So the first thing that's there is everything that you learn need to be in a progressive manner. Just as we did in our session, we started off with warm-up questions, which you were saying were fairly very, very easy, then slightly on the medium side, and then the hard questions at the end. So everything needs to be in a progressive manner. That is something that we teach in our Quant 2.0 course. Now, in our Quant 2.0 course, since it's a progressive course, since it's an adaptive course, we have given out we have gotten the most number of reviews in the period of time that you can see over here. It's not updated. I'll make sure that I update this for the next session that I have. But yes, you can see it's almost 2x. It's more than 2x than any of the competitors that's out there in the market. And why is this so successful? It's successful because we thought to create a product that's adaptive in nature, because every one of you need a unique solution, right? For example, let's talk about the algebra course. We have 84 learning activities, which is around 40 hours of content. Now, if you are a student which is around that Q30th score, you need to go through all the activities. But what if you are a student at that range of Q45? You don't have to go through all the activities. You just need to, fine tune those process skills and the GMAT skills that you need to ensure that you solve the medium and hard questions correctly. Because since you're at a Q45, you can solve those easy questions without any concern. However, what if you're at a Q49 zone? If you're at a Q49, you just need to do a certain number of files because this is the only thing that's remaining out of your plate. Everything else you've already inculcated, right? The 35 activities that you can see, the platform will tell you which are those 35 activities based on your scores, Anmol, right? That is the personalization that we create, because we know that different needs require different activities, and that's the reason we need different courses so that it caters to your current ability level. So the second takeaway is, do not read everything that's there in the book. You need to make sure you only read what you need. You only learn what you need. There's no point learning something that you are already aware of, right? And that is what the expert architecture gives you. It gives you a personalized course based on your ability level. Now, how do you test that ability level? For each of the modules, we have diagnostic quizzes. Once you take these diagnostic quizzes, the platform would tell you, since your score lies in this range and you are not able to solve these conceptual questions, you need to go through these specific files. That would be done by the platform itself. You don't have to do anything. You just have to follow the platform's advice. There are 7 modules. Each module has 5 learning paths. So that makes sure that we have, and that tells me that we have 78,000 courses that can be generated from one algebra course. This generation of course is completely dependent upon your starting ability level that you take through the diagnostic quiz, right? And how do you know that you have excelled? Since you would be putting in efforts, the point is you get evaluation and feedback at each of these points, right? once you go through all the concepts, you get an evaluation and a feedback is done for you. Process skills, GMAT skills, you get quizzes, you have each and every point where we tell you whether you're getting to the right direction or you're going into the wrong direction, right? So the third takeaway is do not study blindly. Make sure you get a feedback the moment you're doing something, because if you study without any data, you are just not understanding whether you are improving or not, right? The expert architecture does a complete analysis of you. It tells you whether you've learned it perfectly, or you need selective revision, or you need to redo the files that you are going through, right? And there are certain success stories as well, and I'll request Harsha to put up those success stories. You can just look at how did they use the course to make sure that they only learn what they need to learn. All the other courses that's there on the market are generalized courses. They're not personalized to you. Now, understand, if Stella is a person who is really good in time and work, but is not that strong in time, speed, and distance, why would she study time and work? She would spend her time to make sure her time, speed, and distance chapter and module is perfectly up to the mark, right? So this is the personalization level that we are talking about over here. We have some really wonderful success stories which talk about how did they use the quantitative course, the quant course, to make sure that they only expend the time they need to expend and not just do the entire course. Right. So if you're a Quant 2.0 student, please make sure you go through the course, follow the expert learning architecture after taking the diagnostic quiz. Diagnostic quizzes are mandatory. Take the quizzes, follow the recommended course structure that the platform asks you to do. And then please make sure that you put in your efforts into mastering process skills and GMAT skills for each of these modules. Now we have all of this into your account. If you want to take a look, you can create a free account as well if you do not have any account. For free trial users, we have added some files. Please make sure you go through those files. If any of you have any conceptual gap, those files will take care of all those gaps that are there. And yes, if you like the course, you can consider purchasing it, right? We have given the files that you can see over here, and all of this is available. Just go to your account. You can access this all for free. So before we come to questions, I would love to have feedback from all of you. How did you like the session? What new things did you learn? Tell me. Yes. I have been speaking since a long time. So so let's just get some feedback over here. What did you like? What did you learn? And how did you like the session? And in that meantime, let me also help you with the session PDF so that you can revise all of this whenever you get time. Okay, I have the session PDF. Some people say you should solve at least 1,000 quant questions. It is not at all necessary, Anmol. We have so many students who literally, and I don't know if you have seen my latest success story. You can just Google, go to YouTube. We had the student Opro, and he was a student who only solved somewhere around 200 questions to 300 questions, and then ended up getting a Q50, if I'm not wrong. So it's important to learn from the questions you solve. That's point A. It's important to understand what kind of questions you are getting wrong so that you can put your efforts to that place. For example, number properties has so many modules, but through data you can understand which are the modules you're struggling with. If you are having 100% accuracy in, let's say, even and odd, you don't need to practice even and odd questions a lot, right? But if you're having a 20% accuracy for prime number questions, you need to practice that more often. So that is something that data helps you do at your own end. Will there be other sessions in the future? Absolutely, Anna. We have sessions both on Saturdays and on Sundays every weekend. You can register for those sessions after you go and visit our website e-GMAT.com. It'll be available at your end, and we make sure that we have the four next sessions lined up in the website. So anything that you feel to attend, you can register through the website itself. With that, let me also give you some other links over here. So let me give you the free concepts link. So this was essentially there. So let me just give me a moment, please. Okay, so this is, and if you're struggling with process skills, you can just go to YouTube over here and get a hold of the process skills videos that we have had. And let me then give you the success story links if you want to check how our students utilize the course to make sure they get successful. Harsha also popped out the wavy line method. If you want to, save this out at your end, please do so. We are also giving out a free mock test if you want to take the SIGMAT test. You can also do that by clicking on this link. So am I going to be informed by email? Yes, you will get an email from us about the next set of sessions. Please make sure to register for that as well. Is this webinar, would this webinar be enough to crack algebra inequalities? Definitely. Algebra, I'm not very sure. Understand, if a 2-hour webinar helps you crack, or 2.5-hour webinar helps you crack entire GMAT algebra, man, it would cost you a bomb, right, as Harsha mentioned. And the amount of content in a 2.5-hour webinar is not that high. And that's the reason why we make sure that even our free trial users are capable enough to solve questions going into the platform, because we make sure that we provide the files that are required for a student to ensure that they're good to go with the concepts and the application of those concepts. Right. Okay. So great. That was wonderful seeing all of you over here. And I'm really very happy to see that you've learned a lot through this webinar. I look forward to seeing all of you in the next set of webinars, and I hope that you would register for them going into the website or from the links that I would essentially, or the emails that you would be sent from us. If you have any other questions or doubts, you can drop that up in our support email ID. And it was wonderful seeing all of you. I hope you learned a lot. I'll again see you in the next geometry session. Till then, take care of yourself and have a wonderful day or a wonderful night ahead. Bye-bye.